Hi folks, we're going to talk a little bit about calorimetry. Calorimetry is the quantitative measurement of the heat exchanges between substances. Okay, quantitative, that means with numbers. So the next video we're going to do some math, but I want to describe what's going on first. So for example, if you've ever seen a farrier work and actually build some horseshoes or get them to the right size to put on a horse, if you take a hot piece of metal, like a hot horseshoe, and put it in a cold bucket of water, what's going to happen is the temperature of the hot shoe is going to go down, and the temperature of the water of the bucket is going to go up. If no heat is lost to the environment, if we know information about the shoe, we know information about the water, we can calculate what the final temperature of the shoe and the water will be. And that process of doing calculations like that is called calorimetry. Now, calorie is an old word that means heat. Metron, or meter, means to measure. So calorimetry is basically the science of measuring heat and how much heat is flowing from one object to another object. So remember, heat flows. Now, there are devices that are called calorimeters. In chemistry class, if you've ever taken a chemistry class, very commonly they use styrofoam cups as calorimeters. And you're given a couple of styrofoam cups, usually two of them nested together with some sort of a insulated lid on top. Why do they use styrofoam cups so often in chemistry? Well, because of the fact that in chemistry often you're using chemicals that are kind of nasty and that would eat away at other kinds of calorimeters. But you put your chemicals in there, you mix something else, you have a little chemical reaction, and you can measure the temperatures before and after. And when you're all done, it's kind of a nice experiment. There are very few dishes to wash. So just an insulated container that you can put a thermometer into and a reaction can occur in. In lab, I like to use a metal calorimeter in physics labs. This calorimeter is a nice calorimeter that actually has some electrical probes on top. When we get into electricity, I actually will use the electrical probes. For our basic studies of heat, we will not be using the electrical probes. But this is an aluminum can. It is insulated. It has insulation all the way around it. There is an inner can, and you can put whatever you want to in this little insulated can. Think of it like a small thermos bottle. And you have heat exchanges in here, and then you can put a thermometer down inside of it and measure changes of heat in this little insulated bottle. There's a third kind of calorimeter that is not commonly used in a simple first-year undergraduate chemistry physics lab, unless you happen to have a fancy schmancy piece of lab equipment. It's called a bomb calorimeter. And the reason it's called a bomb calorimeter is, yes, it could explode like a bomb. Here's what it looks like. And this is, of course, a stylized sketch, but this is kind of the basic parts. You've got an insulated container, okay, an insulated container that will keep the heat in. Inside of this is going to be filled up with water. Within it, there is a sealed chamber, and you put whatever sort of material you are going to test in this sealed chamber. And I hit the wrong button. Okay, I'm going to put something in the sealed chamber. Now, the sort of thing that's real commonly put in there is food. You put some food in there, and this is used very often by dietitians to determine the caloric content of food. How do you think they figured out how many calories are in a Whopper or a fish sandwich or an Egg McMuffin? They have to burn it. So in this container, they put the food. There are some electrodes that are inserted that will actually be the igniters to start it on fire. It is flooded with oxygen. And those of you who've had chemistry, they make sure that oxygen is not the limiting reactant. It gets as much oxygen as it needs to combust. So the food is in there, it combusts away. And when it does that, the food is going to emit heat to the water that is surrounding it. So we all know the specific heat of water. The temperature of the water is measured before and after, and the mass of the water in the calorimeter is known. Well, if we have specific heat, change in temperature of the water, mass of the water, and we can know all of those pieces of information, we can calculate the quantity of heat given to the water by the burning food. And if we use the units calories, we are going to end up with calories. If you worked in a test kitchen for a restaurant, they would give you probably multiple, maybe 20, 50, 100 Whopper Juniors. You would burn them all and you would come up with an average caloric content, and that's what would be printed on the little poster in the restaurant. Now, how the heck do you think they figure out calories for things like 7-Up or beer or milk, things that are liquids? How would you do that? Yeah, you dehydrate it, because water has 0 calories. So you just take the water out and then take the solids that are remaining, put the solids in the little bomb calorimeter, ignite them, they burn, give heat to the surroundings, and there you go. You have a nice way of actually measuring heat transfer. All right, those are an overview of calorimeters. Next, we're going to start doing some math.